Hi folks, today we will talk about the SSI and the IDs as usually, so don't forget to subscribe to my channel not to miss the videos and actually leave your comments, and I'm quite keen to hear what you're doing in the space. Let's hack together. So SSI could live without the IDs for sure, so that you could create the verifiable credentials without the DID, but the DID is crucial if you want to communicate to each other, to identify each other and build some complex exchange protocols. But what current challenge with the DIDs right now, that it's hundreds and hundreds of them. So how to choose the proper one? How to properly choose the DID that will satisfy our needs? So it's the question that was asked by many of people, and one of the good answers, it's the rubic. So it's quite good work. So it's quite extensive catalog of DID methods that try to categorize the DIDs according to different properties. So it's publicly available. It was made in 2021. So I will not go through it because it's a quite extensive one, and I don't want to repeat the paper, but I strongly recommend to read it. But the main key things from there, so it's the characteristics what the DID use for. So first of all, what the DID method? DID method is quite simple. It's for operations that connect our DID address with our with our document. So, and the main thing is two aspects. First of all, it's the network. So what kind of network we use to make these operations, and the registry. So what kind of storage we will use to store actually our DIDs and DID documents. So this one is already quite crucial because they will describe the security and all of the things, and I recommend to keep an eye and keep in mind some provable and secure relation between your hash and actually your DID-doc. Is it any relation or nothing at all? And so just read the paper. I will leave the link in the comment. So another quite interesting concept that was proposed by guys from the Spruce ID, it's the DID traits. And DID traits is somehow similar idea that we have quite big families of the DIDs that could have the common properties. And for example, one of the property could be, could we rotate the keys, or is it just generated once? Or for example, quite crucial one that people not usually think about, and I actually recommend to take this consideration at the beginning, as the cryptography. So it's the cryptography of your public and private keys. So it's the crucial one, and if you share the common cryptography as a trade, you could, for example, switch from different kinds of DIDs. For example, the DID element unanchored, and DID element already, and DID adder, and so on. They share somehow the cryptography with the cryptography similar to DID Ethereum network. So probably all the DIDs that sit somehow on top of Ethereum network will be interchangeable. Why it's so cool that you could switch, for example, from methods that doesn't support the rotation of the keys to the methods that actually support them. So the DID traits is yet another interesting concept, that you try to identify some properties of the DIDs and group the different DIDs based on these properties, and then you could analyze the common properties and make the DMD methods interchangeable, that really could improve the user experience and unlock quite interesting possibilities for the user if the user will be seamlessly change one DAD method to another, or for example, it's a form of representation. Yeah, so that you losing nothing, you don't need to generate a new DAD, but even with the same private and public key pair, you could already express that you have the multiple identities for free. So it could be useful property in different cases. So the deep trace is yet another interesting concept. But if we came to the question how properly choose the DAD methods for my needs, so it's a thing that actually I recommend to consider. I already mentioned the cryptography that you have, what kind of cryptography your libraries support. For us, for example, it's crucial that our SDK it's a cross-platform, so we really picky on the cryptography that could work in a browser, in a backend applications and the mobile phones and so on. So it's heavily based on the TypeScript, so it's always the challenge for us to find the proper cryptography and the libraries and all of the things that will work everywhere. So this one is quite important thing. The next one, is it the DAD method off-chain or on-chain? Because if it's on-chain, what the price of anchoring. And here, for example, we have two families of the DADs. So one is the DAD on chain level 1, so that interact directly with the chain and you pay for every DAD, so it could be quite expensive. Yeah, but another one is the level 2 protocols like side tree, where you pay for the huge batches and then your prices really depend from the side of batches and frequency, how often you generate the DADs. And here we could already see quite interesting thing that, for example, we have a common cryptography. They have a common cryptography for the DIT ether, the DIT element, and for example, DIT polygon. So it's the same cryptography and the same public and private key, but the prices for anchoring will be completely different, because, for example, Ethereum is most expensive one, so the DIT ether will require to pay for every transaction for the user in Ethereum network. When you migrate to the DIT polygon, because it's compatible network with the Ethereum, but much cheaper because the consensus algorithm is different and so on, then you pay less, but you still pay per one DAD. And the most interesting one is actually the side tree. So the DIT element, for example, you already could not say that the exact price of one DAD, because you could have 10k of DADs in one batch that will be covered by one transaction. So it's already quite tasty thing. So you still have the same cryptography, different chains, and compatible chains, so that's the interesting property. And I guess that is quite interesting thing if we could, for example, take the side tree protocol and implement the DIT method that will based on the DIT polygon. So then we will have extremely cheap anchoring, and it's already quite cool. So maybe somebody will build some new DIT method that will do this trick for us, or we will build the same. So, and then we talk about the cryptography, we talk about the on-chain, off-chain. With the on-chain, you know, we get some security benefits, and the cryptography strong things and so on, and the possibility to be the truly decentralized. So here start playing the question of the network and registry is not centralized, the registry is true decentralized. So you should not have doubts that your solution will work with the huge amount of nodes and huge amount of verifiers. So it's a quite important property. Then we came to the question if we still sitting on chain. So it's the propagation time, and the propagation time is quite important one, that you're anchoring of your DID happens not immediately, it happens with some period of time. And here, if we will start comparing, for example, site 3 with the DID polygon, then we came to quite interesting side effects. So the propagation time of DID polygon or any on-chain method will be the time when you will make the real transaction. So this is the transaction time, and yeah, it depends from the network. So it could be from a couple of minutes to, I don't know, even 20 minutes. This could happen. It depends who will pick up your transaction and process it. But for example, if you're sitting on the second level protocol, is different from the implementation of protocol. But for example, for the site 3, you have the anchoring period, yeah, and so it means that you need to sum up your anchoring period, then the transaction time, then some other validators in a network should fetch this data from the contract. So at least I recommend to have the estimation of 2 periods of the anchoring or something similar, but it really depends. So if it's critical to have immediate resolution, then you should either take this yourself or be aware that the propagation time for some DID methods could be huge. That's why, for example, be quite happy with the DID element, because we could use the unanchored version immediately, and then when it's done, use the anchored version and so on. So the propagation time is critical, be aware about it, and maybe if it's so critical, try to find the methods that have the small one, or maybe the methods off-chain that give you the same possibility. So if you're talking about the off-chain methods, it's not so much of them, and all of them struggle somehow from the verification and security thing. But quite interesting one is the DID methods built on the decentralized storages like the APFS. It's a couple of these methods. I will talk about these methods in my next video. So propagation time, cryptography, then possibility to rotate the key. So it's a quite important feature for every DID method. It makes stronger your security. What will happen if somebody will compromise the key? So you should have the possibility to rotate them. So for example, DID polygon allows to rotate the keys, but DID for example doesn't allow to rotate the keys. So you should be quite careful with this property. Another quite important property is the recovery mechanism. So yeah, if we even compromise our keys, and for example we have the possibility to rotate them, so it could be the case that for this you use a different type or separate key that was not compromised and so on. So the recovery mechanism is extremely important. And the same in the same space, the problem of the deactivation of your DID document. So, and it's quite tricky because deactivation could be one time, or you could activate, deactivate your DID documents. So not so much of the DID methods really takes care about the deactivation operation, but sometimes it could be really useful, especially if you try to build different economy models. And yeah, takes care about this. And what I could say that it's critical to take a look if all the features of the DID documents are supported by the methods. For example, could we add different type of cryptography keys to the DID document? Do we have the way to verify them properly? From this feature, a lot of DID methods struggle. So a lot of DID methods doesn't allow to add the external keys that could have the different cryptography. I'm quite keen to find more of them, because it's a real use case that we want to support. And the same, that do not forget that DAD documents have the different properties and the different possibilities. For example, they have not just the key section, but they could have the authorization section, or for example, they have the service section, and together with the service section for the DID-COM, you need to have the way to define the key negotiation, and so your DID spec have a lot of different aspects, and not all aspects are covered by the DID methods. So really make the proper analysis of what potential features of the DID spec and DID documents you will really need, and be conscious about implementation of the concrete DID method. And you know, the last part and the crucial one, it's interoperability. So interoperability actually for me is the two pieces as usual. So the first, I will repeat myself again and again, is the cryptography that we use. Another one, if this method is widely used, is this method is supported by universal DID resolver? Do people actually contribute to the witness and validation networks? How big the network is if we're talking about the on-chain methods, and how other people use it. So that's all that I want to describe about how to choose the DAD methods. So stay with us and have a nice day.